Welcome to my presentation. I am Saurabh Borua. I want to present a topic on motorcycle dynamics. The topic of my topic is on motorcycle dynamics study at signalized intersection. I try to study four topics here. Actually, I get data from sky. Uh, I use the vehicle trajectory data. I try to uh, formulate and try to analyze the four topics here. Firstly, the motorcycle acceleration, deceleration kinematics. Secondly, lateral weaving behavior, characterizing motorcycle lateral weaving behavior. And fourthly, the trajectory-based safety-relevant driving behavior study. The third one, I just pen drop, which is on filtering behavior and gap acceptance in heterogeneous traffic stream, which related to motorcycle. So total four topic I try to formulate or analyzed from trajectory data. Firstly, which is on the acceleration, deceleration kinematics of motorcycle. Secondly, lateral weaving behavior of motorcycle in mixed traffic. Thirdly, the filtering and gap acceptance behavior. Fourthly, the acceleration deceleration heterogeneity uh, in context of safety relevant driving behavior. If we deep dive into topic one, the motorcycle acceleration deceleration kinematic analysis, uh, first, actually five main important information we can gather. Firstly, frequent phase switching. Motorcycle try to switching between speed up, steady speed, and slowing down very frequently comparing to other sort of vehicle or other type of vehicle. Next up part is point is braking gets stronger with speed. When motorcycle go faster, their braking power stands out. The more speed, the more braking will be more powerful. Thirdly, the car accelerate harder compared to motorcycle, especially when the speed is medium to high. The fourth one is fourth one is the motorcycle acceleration depends on rider's decision. It not depends on speed because mostly motorcycle chooses speed based on uh, their choice, not how fast they are moving. Fifth one is the speed does not predict acceleration. Uh, Acceleration of motorcycle does not solely depend on the speed. It actually based on regime or quantile based characterization. So uh, simple regression of acceleration versus speed relationship for motorcycle does not work. We have to use quantile or regime-wise analysis here. So these are the five characteristics. So if we brief up again, firstly, motorcycles frequently switch bit among the steady speed, speed up, and slowing down. With the increase of speed, braking uh, are usually more stronger. Braking power are more strong. Usually, brakes are applied more hardly when motorcycles are speed up. Comparing to cars are accelerate more forcefully than motorcycle, especially at mid to high speed. Uh, Fourth one, if we look at here, we can see that the driving acceleration not solely depends on the rider's speed, it depends on their decision. And fifth one is speed actually cannot directly predict acceleration. We can analyzed or characterized speed acceleration relation by regime or quantile based characterization. Here we have three plots. Firstly, from the figure 4, we can see that the motorcycle, we can see from the red one, the red border plot, we can see that the motorcycle brake harder, then they can accelerate. With the uh, increase of speed, we can see that the braking is little bit harder compared to acceleration, and the difference is getting bigger when speed increases. If we look at the blue plot, we can see that the cars accelerate and brake more harder than motorcycle. With the increase of speed, it is getting more wider. In the blue one, we can see that at a lower speed, motorcycle accelerate at a lower speed, motorcycle uh, accelerate more strongly than braking, but with the increase of speed, we can see that it's flipped. That is, braking is more strongly than accelerate. Next, the second topic, if we look at the characterizing motorcycle lateral weaving behavior under mixed traffic, we can see 5 characteristics here. Uh, Firstly, the motorcycle weave more than cars, and it is noticeable. Lateral movement maneuver per kilometer for motorcycle is much higher than car. Secondly, the motorcycle makes faster and abrupt lateral movement than car. We can actually rarely see the slow lane changes behavior in motorcycle. Weaving is very normal, it's not erratic. In case of motorcycle, it is consistent lateral movement, we can see. Also, rider have distinct style. We can group clear behavior group for motorcycles, especially the riders. There are stable rider to more active maneuvers. Fifthly, the speed alone does not explain weaving. Weaving is cannot fully actually explain the speed or acceleration. Traffic density can also play an important role here. Uh, Here we can see actually 3 plots. I boxed it into red, green, and blue. If we look at the red one, we can see that the weaving frequency depends on rider's style, not on the speed, because within the same vehicle speed, we can see a lot of within the same weaving frequency, we can see lot of speed variation. So we cannot say that the speed is directly related to the weaving frequency. It widely varied. In the green one, if we look at the green one, we can see that relationship between the density and the motorcycle weaving. Weaving is highest at low to moderate traffic density, but in the high traffic density, the weaving frequency is significantly reduced. In the blue box, we can see that the two cluster actually, one is blue dots and another one is orange dot. Blue dot is moderate lateral weaving, and the orange one is stable riding behavior. We can actually distinctly divide in the visuals the lateral movement frequency versus RMS of root mean square of lateral acceleration. We can divide into two groups actually. So these are the three key or important feature of plots we can get from the topic 2. And as I said, the topic 3 information I cannot analyze directly from the trajectory data, so I skip to the directly to the topic 4, which is motorcycle speed and acceleration heterogeneity. And I assess the safety relevant driving behavior. Motorcycle travel faster but slow, show wider speed spread. So speed are spread widely, though its average speed is faster in case of motorcycle. The second one is the speed fluctuation is comparable across different vehicle because all vehicles are in a mixed traffic stream. Motorcycle brake and accelerate less aggressively comparing to other types, especially car and large vehicles. We can see fewer high acceleration events, but lot of lateral maneuver in case of motorcycle. Uh, as a fifth point, we can describe that the speed and acceleration variability are interrelated. It underscore distinct heterogeneity pattern. We can see it. Here also, I am presenting the three distinctive or three remarkable observation from graphical. The red box, we can see that motorcycle have fewer hard acceleration and fewer hard deceleration compared to car and medium vehicle. However, their lateral acceleration is relatively high, little bit high compared to car and medium vehicle. In the green box, we can see that the speed, average speed of motorcycle is little bit high compared to car and medium vehicle, but uh, we can see is spread or skew faster compared to car and medium vehicle. In the blue box plot, we can see that the motorcycle brakes and accelerate more gently compared to car and medium vehicle. So these are the all information I get. So again, if we repeat, my first topic is on acceleration, deceleration, kinematics of motorcycle, then lateral weaving behavior. The third one, which I didn't analyze or can directly analyze using Python code, the filtering behavior and gap acceptance. The fourth one is safety relevant driving behavior I am presenting here. So these are all the topic or information briefly I get from the vehicle trajectory data. So that's it all about. Uh, Thank you so much for watching my video.